All right, everybody, here we go. 6.4, final part of this Chapter 6 chapter. Stratospheric ozone, define on these on page 567 or by any other means that you got. Electromagnetic radiation, EM, and electromagnetic spectrum. So, electromagnetic radiation is the sun emits radiation across the electromagnetic spectrum, peak in the visible portion, so that's the part that we see. Atmosphere protects the Earth from high energy radiation, UV rays, and X rays. The atmosphere does a really good job of this. Also, though, too, it's a good idea to wear sunglasses with UV protection in them, just because there's parts of your eye that'll help you protect versus UV radiation, which is a really good thing. Protective gases, water vapor, CO2, and the ozone. Ding, 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 ding. Ozone, okay? Visible light reaches Earth through the optical window. So infrared is what you feel. It's not visible. Infrared is like heat. Like if you get the heat from the sun, yeah, that's infrared, I'm going to say. So ecosphere absorbs infrared, driving processes in the atmosphere, hydrosphere, and biosphere. So that's really kind of what, it warms the sun up, like the planet. Greenhouse gases do trap that heat. That's what makes one of the things that makes this planet very livable for us. So visible light wavelengths are detected by human eyes. Other organisms, bees, can detect ultraviolet. Humans cannot. So white light consists of many colors. Red is the longest wavelength, and violet is the shortest. You will see this with, let's see, visible light wavelengths. Visible light spectrum. Like this. Alright. Let's go with this. Wavelength. Bam. Alright, let's go images here. Something like this. Yeah, you see how like red's more spread out and the violet is more close together. So, yeah. Visible white light. Photosynthesis. Chlorophylls absorb the blue and red, reflect the green light. So that's why we see the green when we see like leaves. Carotenoids absorb violet and blue-green, but reflect yellow and red. Tomatoes and corn being those. So what you reflect is like what the object reflects is what the eyeball sees. So UV light has wavelengths too short for human eyes to detect. So the wavelengths are just too like close together. So we cannot see UV light. I cannot stress that enough. Although it does not really come on to questions, I will say for ESS. Effects of ultraviolet radiation, UV. All UV types can damage organisms. UVA is 95% of terrestrial UV, alright? But it's the longest wavelength. Causes skin aging, wrinkles, sometimes skin cancer, penetrates glass and clouds. Everybody is susceptible to this. Some people are a little bit more susceptible to it. I pretty much am the poster child for like skin cancer. It's like, alright, Caucasian male of Irish descent, bald, spends a lot of time outdoors. There's other factors. So the result is, yeah, I've had some spots removed from my back already. So, UVB, alright. Oh, this one here. Causes skin aging, wrinkles, sometimes skin cancer. So, yeah. Penetrates glass and clouds. Goes right through. So you want to get glass that is UV protected, like for your eyes. So UVB, 5% of UV radiation, shorter wavelength than UVA. Penetrates the top layer of the skin, blocked by glass. So causes sunburns, damages DNA, linked to melanoma. So blocked by SPF 30 plus above sunscreen. 30 sunscreen is usually what I use. Stuff that's higher, I've just old school, you know, urban myths about it, you know. So like 30 is my sweet zone. Pardon me. By the way, um, personal data for you. Even if you are non-Caucasian, I still recommend sunscreen if you're out in the sun. Reason being because my wife, who is Puerto Rican and she has darker skin, um, but what happened was just like through never would really put on sunscreen, and her skin in some spots definitely is more like what she calls old lady chicken skin. So it's just been sun damage. So if you want to keep like beautiful without wrinkles, um, especially in areas that get hit by the sun, chest right here, neck, face, ears, under your eyes, stuff like that. So, all right, UVC, shortest wavelength, highest energy, absorbed by stratospheric ozone, can be emitted by lasers, tanning beds, used as a disinfectant. Very harmful to eyes. So, yep, make sure you're wearing eye protection if you're anywhere near it. Damaging effects of UV radiation affects the aquatic ecosystem. This damages the phytoplankton, which remember are the base layer of your food chain for ocean life. So, suppresses immune system. We're going to click on this and just go suppress. There we go. Suppresses the immune system. Causes cataracts, cloudy eyes, potentially leading to blindness. You ever seen cataracts? They're pretty nasty. Sometimes you'll see them on old dogs. Sometimes you'll see them on old people. If the person cataract, bam. Yeah, it's that milky white thing on an eyeball. This dude's got it bad right there. So, yep. Best to avoid them. So, cloudy eyes potentially leading to blindness. Linked to skin cancer. Oh yeah, 2020. 1.5 million cases diagnosed. 120 over 120,000 deaths from it. Especially dangerous to children and adolescents. Although they don't feel the effects until later, unfortunately. I mean, sunburns are pretty immediate, but long-term health repercussions are later. Beneficial effects of UV radiation: stimulates vitamin D production, prevents rickets. Yep. You do absorb quite a bit more vitamin D if you are Caucasian. You're just out in the sun. You are hyper efficient at getting it. So, treats psoriasis, vitiligo. All right, used as a sterilizer, kills pathogens. So they'll run eggs through UVC, I believe it is, just to get rid of any pathogens or diseases on the outside of the eggshell. Applications in lasers, forensics, analysis, and lighting. So consider B, see ultraviolet. What is the role of inductive and deductive reasoning in scientific inquiry, prediction, and explanation? Let's look at inductive versus deductive. So go like that, Command C, go like that, go up here for you. Reasoning. So, and we'll go all. Inductive reasoning, moving from specific observation to general conclusion. Deductive reasoning moves from general principles to specific conclusions. Alright? Let's do this one. Verse. Alright. So, yep. There you go, if that helps you out. Okay. Going back to this. Introduction to ozone. Alright, let's scoot on down for this one. Put that right there. Ozone O3 is found in atmospheric layers. You should know this too, by the way. IB will love throwing that onto an exam, I'm willing to bet, just to see who knows what if O3 is ozone or not. So it's found in 2 atmospheric layers. Stratosphere, which is good, blocks the UV light, protects life, not a cause of global warming. Yes, we like ozone in the stratosphere. All right, in the troposphere, it is bad. Acts as a greenhouse gas. It's short-lived, but it traps more heat. So, yep. So atmosphere. Keep this in mind. Ozone, stratosphere. Muy bien. Bueno. Troposphere. Ay, mala. Que mala. All right. The ozone layer, located in the lower stratosphere, 15 to 40 kilometers up in above us. So, absorbs 99% of UVC, most of UVB, and 5% of UVA. Keep in mind that most of the UV radiation that reaches the Earth is A. So, this this takes care of all the low-hanging fruit, but it still absorbs some of the UVA, but UVA, for my money's worth, is probably the big problem. So up here, yeah. All right. UVC is most dangerous, so its absorption is critical. I will give it that. I wish this absorbed a little bit more of the UVA, but the UVC, like without that ozone layer, we are cooked. So, yep. Ozone exists in dynamic equilibrium. UV breaks I need you to understand this. So, UV breaks oxygen into oxygen atoms, and it forms O3 from that because you've got these free oxygen atoms, and then it's real easy to recombine them. Think of them as like, you've got like three like O2 units, and then what happens is these ones break, and now they're free, and now you can form O3, where before you just had oxygen, which is O2. So, ozone is constantly formed and destroyed. So it's like Ambrosian oil. So basically, it's like fireworks. It's like they form, they deform, they form, they deform, they form, they deform, which makes it kind of hard to measure, I'd imagine. So, depletion of stratospheric ozone, the ozone hole. This is what we talked about, like we can talk about the hole over Antarctica. Observed since the 1970s, particularly over Antarctica. Satellite data shows seasonal thinning spring due to ozone depleting substances, ODS. Figure 5 shows extent of ozone. It's in the book. Figure 5 shows extent of ozone holes, 1979 to 2021. I wanted to show you this. Let's go here. Oh man, that didn't work. Sorry, gang. I have not had my coffee yet this morning. Although I did go on a tour of a coffee plantation yesterday, and it was amazing, the biodiversity they had there. And it really makes you appreciate what good coffee farming does for the environment. Alright, let's see images here. Alright. Alright, sorry, the quality really isn't there. But you can kind of get the vibe here. Basically how it was increasing. Increasing. Trying to decrease maybe. So let me see if I can get a better image. Hard to do with my face in the way. No. Wonder if it works if I blow it up a little bit. Nope. Alright. goes left to right and then down. So 1980 to 2001. So you can start to see how it increased all the way up through 2001. So, yep. All right, peeps, back to this. I'm going to bring my noggin right over here. Good. All right. More UVB reaches surface, affecting ecosystems and your health. So that's the problem with the ozone hole. So it's just we got more UVB coming on in. So, all right, let's go down here. Let's talk about what causes these ozone depleting substances. Yep. Otherwise known as ODS. So they love using acronyms and all that for an IB. And ODS is one of their favorite when they talk about these. So they just assume you know that ODS means ozone depleting substance. Human-made chemicals are CFCs, HCFCs, HFCs. So these contain chlorine or fluorine. CFCs and HCFCs are both ozone depleting substances, greenhouse gases. But HFCs are not ozone depleting substances, but they are greenhouse gases. So that's a key difference. Remember, HCFCs, not ODS, but GHG, greenhouse gas. They're less harmful due to shorter lifespan, basically. They do trap heat, though, so they're not completely, sin-free. We're phasing out CFCs, HCFCs, and replacing them with HFCs. So the action of ozone depleting substances. CFCs are used in aerosols, like any can that you spray. Try to avoid getting those. I mean, obviously I shave my head, and I'm no stranger to shave cream. But I've been trying to use a shaving bar or soap that doesn't have it come in an aerosol can, just because of, I think there's other ways around it. Foams will have it, like a lot of fire extinguisher foams. Pesticides as well. Refrigerants is huge for these. This is why dumping a refrigerator in the forest is so bad, just because it's so if it has CFCs or HCFCs, those go on off and really just burn out through the ozone. It's also too why if you've got a leaky air conditioning line in your car, why you just can't keep topping it off, filling it up, and then replacing it with Freon, every 6 months or so, because it really does burn a hole through the ozone. So, all right, at the ground level, it's stable, but which is really cool, non-explosive, safe, all this stuff. Yay, right? In the stratosphere, though, UV breaks them down, releases chlorine, which destroys the ozone. Remember, chlorine is what they put in your pool to kill bacteria and germs. It's also what you can do to make chlorine gas. So, do you really? Is it much of a surprise that it destroys the ozone? One chlorine atom can destroy thousands of ozone molecules. Yep, it's pretty good at it. Strategies for reducing ozone depletion. Public action. Banning CFCs in spray cans. That's just numero uno right off the bat. Strategies include replacing CFCs and HCFCs with safer alternatives, up here, HFCs. Also, too, hopefully they're coming out with other products as well, more propane driven, I guess, and stuff. Recover, recycle ozone depleting substances from appliances. Enact legislation for safe disposal. Capture from air conditioning units. So, yep. So, when you take away an air conditioning unit, that's another one where you just don't want to dump in the woods, just because it has that freon with it, and it gets off in the ozone, destroys everything. So it's really important to recycle those. dehumidifiers as well. All right, Montreal Protocol, 1987. This is an international treaty to regulate and ban ozone-depleting substances. And they love asking questions about the Montreal Protocol on IB exams. At least they have, but they just obviously came out with a new book recently. So we'll see if they continue to do it or if they think the Montreal Protocol, which was in 1987, is now an historic event. International treaty to regulate and ban ozone-depleting substances. What was really pretty cool was that bans CFCs and similar chemicals, monitors and adjusts the implementation over time. Most successful example of global environmental cooperation. That's the part that was really cool about the Montreal Protocol. Like, everybody got together, regardless of religion, politics, whatever, and they hammered this out and they actually followed it, which is really pretty cool. For the most part, they followed it. Timeline in CFC reduction. 1970s, ozone depleting substances. Concern rises. The 1970s is like, yeah, that's not so good having a hole in the ozone. Kind of lets that light in a little bit more. Antarctic's ozone hole, discovered. 1985, there's duh, it's real, all right? Montreal Protocol was signed 1987. You see how fast that was? Hole discovered 1985 to 1987. We got to act on this. And people getting hammered it out within 2 years. And that was even before cell phones. 2000 to 2012, significant reductions in it, in ozone depleting substances. So, hey, implementation took a little bit longer. It took closer to 13 years to really start, and then really more so with 25 years. So, and then 2019, the Kigali Amendment to phase out HCFCs by 2040. Let's see. We're already working on the best thing we have right now, HFCs, and we're working on getting them out, and doing even better by 2040, which is in 15 years. So, significance and success of the Montreal Protocol prevented severe global ozone loss. So, it made it so that didn't happen. Made personal through health risk. Made personal. Yeah. Basically, what they mean by that is when you start affecting everybody's health, everybody's like, maybe we should get together and do something about this. It's kind of screwing us all. So satellite data helped visualize the impact. It's just irrefutable data. And it's very optic too. Most 80% of the people out there are visual learners. So when you see something visual, it's like, all right, yeah, I guess it's true. Solutions were practical and scalable. So it's like, hey, we had solutions in place to them. A model for other agreements. This demonstrates international cooperation, use of precautionary principles, as opposed to it being too darn late, scientific collaboration, and economic flexibility, effective monitoring and regulation. This was all through with the Montreal Protocol. Continuing challenges. CFCs persist in the atmosphere for 50 to 150 years. So those CFCs that we were using in 1970, at best, they're just getting out now, and more likely they're going to be around for the rest of your lifetime, even though it was before your lifetime. Low-income countries still are allowed to limited use of HCFCs. And for my money's worth, I would not even allow that. I would just be like, hey, look, you're just starting off with the best technology. Just get rid of, altogether HCFCs. Implement. I'm sorry. No, I'm sorry. I had that all wrong. LICs are still allowed to be using HFCs, which are one of the better products they have out there right now. So, illegal markets for ozone depleting chemicals. So, this is true. When I had a heat pump, which is kind of like an air conditioning unit that, for lack of a better, for just general understanding, heat pumps will heat your house and they'll cool it like an air conditioner. All right, that's an oversimplification. But they're taking away my old air conditioning unit, and I was seeing like, okay, do I need something new here, or can I get by another year with this? And they're like, well, here's the deal on this. We won't be able to service this in a year or two because of the Freon you have in there. And it's only an air conditioning unit that's 20 years old. But they're just like currently we're able to take out the Freon, put it to a plant, recycle it, clean it up, and then reuse it. But in a year or two time, like, that's going to be illegal, and it's all just going to be black market stuff. Um, and then, that's just, I'm like, damn. So that is actually true. Because people are just like, I like my old air conditioning unit. I don't have thousands of dollars to buy a new one. I'm going to just go on the black market and get some old nasty Freon, like that's dirty, that's been used for 20 years and probably doesn't have much lifespan left, but it's immediately cheaper. Volcanic eruptions and climate change can also influence ozone. Volcanic eruptions affect everything. Monitoring is ongoing, obviously. Planetary boundary for ozone depletion. The Montreal Protocol has prevented the crossing of this boundary, which is good. Ozone's still within the safe zone, generally. More on ozone reactions with CFCs and HCFCs. Remember, these are the really baddies that we had back in the day. Ozone depletion substance release halogens, chlorine, breaks down the ozone. So remember how that chlorine, basically it just, it takes those ozone molecules and wipes them right out. Ozone essential for life. Originated from blue-green algae. Yeah, interesting, right? It's one of the unique things about our planet versus Mars. Protects life from UV. Enabled land colonization and the Cambrian explosion. So, why ozone holes at the poles? All right, we'll get that one there. The poles have lower natural ozone concentration. Human-made chemicals causes greater ozone reduction there. So, yeah, it's just the way it is. It's thinner there, so guess what? It's going to break through first. The issue of HCFCs. Hydrofluorocarbons were developed to replace ozone-depleting substances. HCFCs are not ozone-depleting substances, but are potent greenhouse gases. So, yeah, they don't deplete the ozone, but they trap heat like you wouldn't believe. They have a global warming potential ranging from 12 to 14,000, just under 15,000. They remain in the atmosphere to 10 to 20 years, and eliminating them could prevent a 0.5 degrees Celsius increase in global temperature by 2100. So eliminating them would really help us reach that 1.5 Celsius goal. So this is widely used in air conditioning, refrigeration, foams, aerosols, fire extinguishers, and solvents. All the stuff that we talked about with ODSs. So fridges and air conditioning units. There are 1.9 billion AC units globally, and it's only going to go one way. All right. Right now I'm filming this in an unair-conditioned bedroom in Puerto Rico. Luckily it's 7:49 in the morning, but I'm going to tell you, it's kind of steamy and hot. So, oh yeah, and the month is July or June. So, yep. Let's see. AC and fridges are energy intensive. When you start looking to live, if you're looking to live way off in the country, like, if you're looking to live like off the grid where you don't have power lines connected to your house, you basically are just running off of a generator or running off of solar panels or running off of like however other energy sources. From what I've heard, some of the biggest energy hogs are water pumps, and like air conditioning is just pretty much out of the question. So, and the reason for that, it's just constantly running, it uses tons of energy. It accounts for about 10% of global CO2 emissions, 3 times that of aviation plus shipping combined. So, yep. And I will say that is AC and fridges. When you look at how we used to, refrigeration is relatively new, I'm going to say within the last 150 years, probably more like 100 years, really. Before we had refrigeration, we had ice boxes. In the winter, they would carve ice out of way up north, pack it in sawdust, put it in a barn, and then just keep it like that all like, and hopefully it made it all through until the next winter. They would also ship ice. Now, the whole industry of just shipping ice, like from New England, frozen lakes, down to the Caribbean. Yeah, kind of crazy. Um, but it's what they had. It's what they did. All right. Many refrigerators and ACs contain CFCs, HCFCs, and HFCs. Disposal is important due to persistent ozone depleting substance leakage and then destroying the ozone. Yeah, risk of ozone depletion once it leaks. So, refrigerant process. So, fluid changes between a liquid and gas. So, and then it transfers that heat on out. So not all refrigerants are captured when old units are disposed of, especially those air conditioning units that are seen thrown out into the woods and then they just let Mother Nature disintegrate. So something in mind, look for your local, in the United States, look for your local town hazardous waste day. You can drop them off there and they will take them. Proper waste management is crucial. High temperature incineration can destroy 99.99% of ozone depleting substances. So, yeah, they take those CFCs, HCFCs, and what they do is they burn them, but at a really high temperature. Now, they probably get energy from that. So, hey, feel good about that. But, like, they're not, the thing is, more importantly, they're not really going to be destroying the ozone. So, all right, here we go. Some stuff to look at right here. Let me see if I can create as much room as I can for these. All right. Figure 3A, average hourly variation in ozone on wet and dry days in Guarujá, Brazil. Keep in mind, in yellow, if you're in my class, I don't expect you to copy it down. So, now, this is average hourly variation in nitrous oxide on wet and dry days in Guarujá, Brazil. And figure 3 is average hourly variation in sulfur dioxide on wet and dry days in Guarujá, Brazil. So, yeah, right? Just like that. So, we got questions down here. First 2 questions. Identify the time of the day that the ozone is at its lowest concentration on a wet day in figure 3A. So if you've got any ability to read a graph, so it's like at what time of the day is the ozone at its lowest? It's going to be right around here, between 6 and 8. Now you know what number is between 6 and 8, or if you don't, God help you. So, outline why the highest concentration of ozone occurs at the time shown in figure 3A. So, why does it occur highest? You got to know that this is on military time, so it's like 1400 is 2 o'clock in the afternoon. So, you should know that starting at like 2 o'clock in the afternoon, and it looks like it goes highest until like 4 o'clock. All right. So that's when the sun's the strongest. So solar radiation just promotes ozone production, when you got sunlight and the heat. Traffic is also highest right around then. That's when people are going home. All right. Yeah. So, and also too, that's when like factories are producing stuff as well. And the temperature definitely has a link with the ozone concentration. So, yeah. All right, next question. Moving on down. Describe one impact on human health of high ozone concentration in the air. So, this can irritate eyes and cause respiratory issues if the ozone, if it's a high ozone concentration in the air. Outline one possible source of the pollutant shown in Figure 3b. So, this one right here. Could be burning of fossil fuels when I'm looking at 8 a.m. here. Just with power plants, electricity starting on up. All right. Also, motor vehicles. Remember, 8 a.m. is also rush hour traffic for a lot of places. Manufacturing goes into effect for manufacturing like things like fertilizer, cement, oil refinery, all that sort of stuff. All right. Yeah, so that's why for nitrous oxide. So in Figure 3b. Also incineration of waste. We do this and we call it biomass, okay, where we basically pick up trash, burn it, and then get electricity from it. So, all right. Outline why sulfur dioxide levels are lower on wet days than on dry days, as shown in Figure 3c. And it's just because sulfur dioxide dissolves in water and then forms acid rain when it comes down. So then it starts the acid rain, basically deteriorates statues, anything with concrete or limestone in it. Evaluate a strategy to manage the effects of one pollutant named in Figure 3b or 3c. So let's take a look at that one a little bit more. So let's talk about replacing the use of fossil fuels with alternative energy. Now, the good thing about it is it eliminates emissions totally. Now, the bad news is would be a major societal change. Also, too, it would involve money. So, you need a society that's really got like a strong environmental or ecocentric like vibe or principle. So, for that one. All right. Let's talk about putting on catalytic converters. It would remove nitric oxide. You can continue to use fossil fuels, which is like not a hard sell for people. I mean, they're like, okay, I just continue the way I am. I just put this catalytic converter at the end of my exhaust on my car. The emissions of other pollutants still go out. It just gets rid of nitric oxides. So it's easy to introduce. You just put it onto a car. For all new car sales, you mandate that it has to have a catalytic converter. So other one could be a cleanup of, this one's a little bit more, we get rid of both nitrous oxide and sulfur dioxide. Clean up acidified aquatic systems, basically, using lime. So it's like where you just dump lime into a lake. It's easy to apply, but it's expensive, and it does not remove the root cause, which is us putting sulfur dioxide and nitric oxide off in the atmosphere, and then it comes down as acid rain, which will then acidify the lake and the water system all over again. So then you got to repeat it. So, yep. There you go. That's how we're going to evaluate those strategies. So, all right, figure down here. Ooh, better make myself small here. All right. There we go. Remember, anything in yellow you do not have to copy down. Figure 2, mean monthly regional change due to the 2020 COVID lockdowns in A, oxides of nitrogen, NOx emissions, and tropospheric ozone layers. So here we go for this one. Nitric oxide emission reductions. Hey, who's winning here in 2020? Yep, quite a few countries. So you saw in February, starting to reduce. March, starting to reduce. April, dang. May, dang. June, lockdown, dang. All right, big time emissions. Ozone reductions. So Yep. Hey, a little bit. Hey, we're getting somewhere. Oh, now we're on a move. Ding, dang. All right. So, identify the region that shows the greatest nitric oxide emission reductions in February 2020 isn't as shown in figure 2A. So this one right here, you go to February right here. What color do you see strongest? Asia, Middle East, the orange. So outline one reason for the nitric oxide emission reductions during COVID-19 lockdowns is shown in figure 2A. Hey, look, they're just burning less fossil fuels. All right, you didn't have to drive to work. Also, too, that you weren't making anything because you couldn't sell anything. So the factories weren't burning through fossil fuels. So, explain the relationship between the nitrous oxide emissions shown in Figure 2A and the tropospheric ozone concentrations shown in Figure 2B. So, sorry, everybody. As nitric oxide decreases, so does the tropospheric ozone. So that's basically the link that you see right there. This is because nitrous oxide can lead to tropospheric ozone formation. So when the nitrous oxide, because it interacts with sunlight, and that's, produces the ozone. So if you've got less over here of nitric oxide that can interact with sunlight, you're going to have less ozone reductions. So, yep. Outline two impacts of tropospheric ozone on living systems. It damages the leaves of plants, all right? And because the leaves get damaged, it decreases photosynthesis. The plant does not really grow as big and strong, which reduces primary productivity. So, loss of habitat and food, because we have less plants, it's less food and habitat for human beings and animals. So, reduction of biodiversity. Also increases respiratory diseases and eye irritation as well. So, generally not a good thing. All right, tropospheric ozone is a major component of photochemical smog. Outline two conditions that contribute to high levels of photochemical smog in an area. So one is having mountains and valleys. It basically traps it in the valleys. So if here you are, like you live here in the valley and up here are the mountains, it really protects against the breeze. So the result is that smog just settles in there and it does not move. I have been in a valley in the Alps and seen this, and it is for real. So that's why in valleys they're big, like against traffic congestion, because they're like, absolutely not. That exhaust from your car is not going to go anywhere, and it's just going to sit, and we're all going to be breathing it in. So high pressure and weak winds can cause it too. Remember, wind is great for moving that smog right along and moving it out. Without it, it's just going to be sitting right there stagnant. It's kind of like where we live in Hartford. You know how there is very little wind, it feels like, in June, July, August, and September, and the humidity's high? And basically, that's really what contributes to that photochemical smog. So, urban density, the more people you have, the more fossil fuels get burned. All right. Also, burning a forest. A few years ago in the summer, we had those forest fires up in Canada. Still kind of do from what I've heard. But these were big ones. And it brought all that ash down and really created like a smog atmosphere for us where you're looking out during the day. You didn't want to really go out because it's just nasty. All right. Nitric oxide also contributes to acid deposition. State one method that could be used to restore an ecosystem damaged by acid deposition. So with this, liming of lakes, you could go after reforestation, planting acid resistant plants to bind soil and stuff. Yeah, those would be some good ones. So, alternative refrigerants. New natural refrigerants are emerging with low or near zero global warming potential. Ammonia, CO2, and propane. Problem with propane is it's a gas, like it can explode kind of. So, challenges: toxicity for ammonia. Yeah, that's kind of nasty. I know for ammonia, if I smell it, it sears the inside of my nose. I'm just like that, and like sneezing for a while. Flammability, propane. Yep, nothing like a good old like firebomb explosion. Major companies are shifting away from HFCs. The European Union has already phased out HFCs in supermarkets since 2015. It's actually a really good start of legislation. All your refrigerators in the supermarkets since 2015. Nope, can't have any of that stuff. So, alternatives to AC units, traditional cooling methods being reconsidered, meaning they have already existed. Wind towers in the Middle East. These things are, if you ever wonder why, like, wind tower, birthplace of civilization, they're these right here. So these things are crazy. The book has a great illustration on them. Might go into them in my class. So here's how they basically work. Images for wind towers. Come on, man. Oh, this is a good one here. Come on, blow big. So what happens is here you have your building. Like here you are with your television, like living your best life. Oh, by the way, keep this in mind for when you've got an apartment. You can have like allergies if you're living in the basement, but generally the basement is warmer during the winter and cooler during the summer. So guess what? Your energy bills are quite a bit less. So here's how this works. Wind tower here. So the wind enters. You got to know which way the wind usually comes from. And here in New England, a lot of the wind comes from the west, southwest. So it comes on down this way. Way cool, right? Enters the cooled basement, which is really pretty cool. What you do is you basically have this well here, and there's an air drawn into the basically your cistern or quanat. So what it ends up doing is that air, when it enters, it draws air on up through, and that water is cold, and it transfers basically a lot of that cold air, which this, like cold moist air is going to take away heat a lot more than cold dry air, and brings it up here, and that's where you live your best life. And then all that hot air goes up and out. So these are really pretty darn cool way to live. So all right, back to this. North facing cold rooms in Europe. So yeah, that's where they would store some ice and some other stuff, because north facing in Europe is away from the sun. Underground ice houses, yeah, those are some old school ways of doing it. That's used to before refrigerators. I guess they would do this in Alaska because the ground is really cool during the summer. They just dig a hole and then fill it up with snow and ice during the winter and hunt, and then that's where you would store your meat. So, design adaptations for modern buildings can reduce reliance on air conditioning. There's a lot that goes into this. The houses in Puerto Rico, right behind me is a cement wall. It does tend to face the afternoon sun, so this room does warm up. But the thing that they do is they have windows on either side, so there's a cross breeze. So the wind is constantly flowing through, taking out the hot air and putting in fresh air. So, which is really pretty cool. Things like shades will do quite a bit as well, so it protects against the sun. Wind towers or wind catchers. Traditional Iranian architecture. You might be able to ask math teacher in our school. Oh my God, Amir. Okay, Miss Amir about it. For passive cooling. Night air is denser and cooler. So, yep. The cooler air displaces the hot air, which rises and becomes trapped. Openings in the tower at the top allow hot air to escape. So, Cooling mechanism. Cold air from the tower courtyard flows into rooms during the day. It enhanced design. Linked to Ganat's underground water tunnels. Yep. Cools air further using the Bernoulli effect, which lowers the temperature by 15 degrees Celsius a ton. Used for over 1,000 years. Yep. When my relatives were trying to scratch well, not even potatoes 1,000 years ago, scratch a living out of Ireland, you know, these people were cooling themselves and living a cool life. Yep. Great cultural experience. So, all right, everybody. That's it. That's my best. And, yeah, have a great day.